Welcome back. As promised in the previous class, we are going to give more examples on how to find conjugate harmonic functions. So this is the next example. Given u of xy is x cubed minus 3xy squared plus 3x squared minus 3y squared. Find v of x, y such that f of z given by u plus iv is harmonic. This is the same thing I'm asking you, that just simply find the conjugate harmonic. Conjugate is analytic, not harmonic. Find the conjugate harmonic function v. So say that f of z is analytic. This is just to say find the harmonic conjugate of u. Now, two functions u and v are conjugate harmonic if and only if they satisfy the theory. So solution, u and v are conjugate harmonic if and only if partial u partial x equals to partial v partial y, and partial u partial y negative partial v partial x. So that's by definition. So then let's get partial u partial x. Now from the function partial u partial x, you should get the answer to be 3x squared minus 3y squared plus 6x. So call this this is the same as partial v partial y, and partial u partial y is equals to minus 6xy minus 6y. This is the same as negative partial v partial x. So then this implies that partial v partial x, so divide through by negative, so we'll have 6xy plus 6y, all this one equation 1, and partial v partial y will be 3x squared minus 3y squared plus 6x, all this one equation 2. So that's step 2. Next step is from calculus. So from calculus, we know that the v is partial v partial x dx plus partial v partial y dy. So dv will be partial v partial x is 6xy plus 6y, and then dx plus 3x squared minus 3y squared plus 6x dy. All this one, question 3. Now integrate both sides of 6, i.e. integral of dv integral of 6xy plus 6y dx plus integral of 3x squared minus 3y squared plus 6x dy. So the integral of dv is v. So we'll have v. This is with respect to x. So this will be x squared, then 3x squared y. This one will be 6xy. Constant of integration will add at the last step. Here with respect to y, we'll have 3x squared y. This will be minus y power 3 will be plus 6xy and then plus c. But when you are carrying out such problems, you're finding conjugate harmonic functions, after the process of integration, you don't stop there and then just add the terms. Observe the answers you have. If we have terms which repeat, don't add them, but just pick one out of those common terms. Like we have 3x squared y and 3x squared y. So you cross in one. Only pick one of the two values. Don't add them to say now they're 6. So cross in one. Similarly, 6xy and 6xy are common. So also cross in one of them. So finally, the correct form will be now those unique terms and all those you pick which are common, pick one of them, not just adding them. So therefore, the correct form of v of xy will be 3x squared y plus 6xy minus y cubed, then plus c. 3x squared y plus 6xy minus y cubed plus c. So that's what you're supposed to do. Example 2. Find v of xy given that f of z equals to u plus iv is analytic and u of xy is given by x squared minus y squared. So when they give you this instruction, it is the same thing as just simply asking you find the conjugate harmonic of the function u. So solution. F of z equals to u plus iv is analytic if and only if partial u partial x equals to partial v partial y and partial u partial y equals to minus partial v partial x. So these are what we call the CRE, the Cauchy-Riemann equations. So let's get partial u partial x, leave us 2x, call it equation 1, and partial u partial v minus 2y. call this one equation 2. So from these Cauchy-Riemann's equations and 1 and 2, we clearly see that partial v partial x will be, because it's a negative of this one, so it will be 2y, and partial v partial y is the same as partial v partial x, which is 2x. So call this one 3, call this one 4. From calculus, we also know that dv of the dv is partial v partial x dx plus partial v partial y dy. So we replace, we have dv equals to partial v partial x will be 2y dx plus partial v partial y is 2x dy. Call this one equation 5. So then now to get b from 5, you simply integrate. So integrating 5, we'll have integral of dv, integral of 2y dy dx plus integral of 2x dy. Integrating dv is b, this will be 2xy plus 2xy plus c. Because we have repeated terms, then just pick one. So delete one. Therefore, v of xy is 2xy plus c. And you can actually confirm that this is a harmonic function by simply getting the partial derivative. So if you try partial v partial x, you get 2y, partial squared v partial x squared, you get 0. Partial v partial y, you get 2x. Partial squared v partial y squared, you get 0. And clearly, partial squared v partial x squared plus partial squared v partial y squared is 0 plus 0, which is 0, and shows that v is harmonic. So that is how we do that problem. Thank you.